Special angle proofs. Some assumptions can be made about angles and line segments from a drawing. Valid assumptions from this drawing are that segment HIK and segment GIJ are line segments, angle HIK and angle GIJ are straight angles, angle HIG and angle KIJ are vertical angles, angle HIJ and angle JIK are a linear pair, which then would make them supplementary. Points H, G, and K are non-collinear. Point I is between points H and K. Point I is between points G and J. And point K is below and to the right of point G. The following assumptions cannot be made. Angle G and angle J are right angles. They could be obtuse, they could be acute, they could be right, but they don't have to be right angles. That's why they're not true. Angle H and angle K are not congruent to one another because we don't know if the line segments HG and JK are parallel or not. Similarly, we don't know that angle G and angle J are congruent for similar reasons. We cannot necessarily say that HG is greater than JK. It appears that way in the picture, but the diagram may not be drawn to scale. Similarly, GI is not greater than IJ, and HI is not greater than IK. We also cannot automatically assume that line segment HG and line segment JK are parallel to one another. That would have to be given information if it was indeed true. In summary, if something looks like a line, a segment, or an angle, it is. However, the relative measure of segments and angles are not to be trusted unless it's given to you at the beginning of the proof. An angle that looks smaller in measure may actually be bigger in measure because the diagram may not be drawn to scale, and a segment that looks shorter may actually be longer. The properties and assumptions discussed will help us prove many theorems, but for now, let's prove one that we already know, the vertical angles theorem. Vertical angles are congruent, and also introduce two new theorems by proving them. The complementary angles theorem states that adjacent complementary angles form a right angle, and the supplementary angles theorem states that if angle ABC is a straight angle and D is a point not on segment ABC, then the linear pair angle ABD and angle DBC are supplementary. We will begin by proving the vertical angles theorem. We are given that segment EC and segment AD intersect at point B, and we're trying to prove that angle 1 is congruent to angle 3. Whenever we start a proof, we need to begin with our given statement. So we write down that segment EC and segment AD intersect at point B, and it's given to us. Now, because we have these two lines that intersect, we end up having two pairs of angles that add up to equal 180 by the angle addition postulate. So let's start with the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And then we can also say that the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. And now notice we have 180 degrees on the right side of each of these equations. So we can actually take the left side of the equation in step 3 and substitute it in for 180 degrees in step 2. That will give us the equation the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. And again, that was by substitution. And then notice we have the measure of angle 2 on both the left and right side of the equation. So we can subtract the measure of angle 2 from both sides, leaving us with the measure of angle 1 is equal to the measure of angle 3. And then by the definition of congruent angles, we have that angle 1 is congruent to angle 3. And we have proven that the vertical angles theorem is indeed true. Now let's prove the complementary angles theorem. We are given that angle ABD and angle DBC are complementary angles. We need to prove that angle ABC is a right angle. Well, let's start off with our given statement. angle ABD and angle DBC are complementary angles. And then because we know they are complementary angles, we can say that they add up to equal 90 degrees by the definition of complementary angles. We can also see in this diagram that angle ABD and angle DBC, if we take their measures and add them up, we will end up getting the measure of angle ABC by the angle addition postulate. So since we have the measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC, and the measure of angle ABD plus the measure of angle DBC equals 90, we can conclude that the measure of angle ABC is equal to 90 degrees by the transitive property of equality. We took this middle expression that occurred in both out and set the beginning equal to the end. And then, by the definition of a right angle, angle ABC must be a right angle. Now let's work through the supplementary angles theorem. We are given that angle ABC is a straight angle and point D is not on line ABC. And we need to prove that the linear pair angle ABD and angle DBC are supplementary. Well, let's first start off with our given statement that angle ABC is a straight angle and point D is not on line ABC. And then because angle ABC is a straight angle, we can state that ray BA and ray BC are opposite rays by the definition of a straight angle. And because they are opposite rays, we can then also say that angle ABD and angle DBC are a linear pair because the non-adjacent side form opposite rays. We also know that the measure of angle ABC has to be 180 degrees by the definition of a straight angle. We can also say that angle ABD plus angle DBC, when we add their measures up, they will end up adding up to the measure of angle ABC by the angle addition postulate. Then if we use the definition of a straight angle and the angle addition postulate together, we can then state that the measure of angle ABD plus the measure of angle DBC is equal to 180 degrees by the transitive property of equality. We took the common measure of angle ABC out of the middle when we applied the transitive property. And then since the measure of angle ABD plus the measure of angle DBC equals 180 degrees, we can say that angle ABD and angle DBC are supplementary by the definition of supplementary angles. 5 theorems have been proven so far. We have the common segment theorem, the common angles theorem, the complementary angles theorem, the supplementary angles theorem, and the vertical angles theorem. In addition to theorems being proven, they can now be used as reasons in a proof. Each new theorem that is proved will help develop new ideas that allow for a better understanding of increasingly more complex geometric ideas. Let's try to work through another proof of a theorem called the perpendicular lines theorem. The theorem states that if two lines form congruent adjacent angles, then the lines are perpendicular. We are given that the measure of angle 1 is equal to the measure of angle 2, and we need to prove that M is perpendicular to N. Let's begin with our first statement. We have the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. We can say that based on the angle addition postulate. Then we have the measure of angle 1 is equal to the measure of angle 2. That's given to us. And then since we have the measure of angle 1 equals the measure of angle 2, we can substitute the measure of angle 1 in for the measure of angle 2 in the first line. And when we do that, we will get that the measure of angle 1 plus the measure of angle 1 is equal to 180 degrees. Then if we combine like terms, we get 2 times the measure of angle 1 is equal to 180 degrees. And then if we divide both sides by 2, we will end up getting that the measure of angle 1 is equal to 90 degrees. And then since the measure of angle 1 is 90 degrees, angle 1 has to be a right angle by the definition of a right angle. And finally, we know that M is perpendicular to N by the definition of perpendicular lines.